Bar charts are one of the most popular ways to visualize your data. You'll be hard-pushed not to find a bar chart during corporate business meetings, science seminars, or even during news broadcasts. The reason for that is that bar charts are among the clearest and most straightforward visual representations of information. As such, they are also easily interpreted by an audience irrelevant of their technical qualifications or background. That's why it is likely that you will also be using this particular form of visualization regularly. Therefore, mastering the bar chart will be one of the most fundamental skills you gain throughout this course. We'll create a bar chart using data about used cars. We have a data set containing two columns. The first represents the car brand, while the second, the number of car advertisements of that brand. This data set is rather simplistic, but extremely fitting for an introduction into charts. Rest assured that even if you're a beginner in the field, you'll quickly get used to creating and styling charts. We'll also discover the Excel, Tableau, Python, and R built-in functionalities that help you create bar charts with ease. Exciting stuff! Can't wait to kick off! Here, we'll discover how to create and style our charts so they look professional and ready for any presentation. Without further ado, let's get started. We'll go ahead and open our file called bar chart data. Our data contains the following two columns, brand and car listings. All right. We'll invest a bit of time in formatting our Excel sheet to achieve a professional look. We'll keep the raw data in this sheet and instead work on our graphic on a separate Excel sheet. Let's start by selecting any cell containing data. Then, by pressing Ctrl and A, we can grab all cells from the table. Let's copy them with Ctrl and C and place them onto a new sheet. We won't be placing the data directly into the first cells, as they will be reserved for formatting. Instead, let's select the cell B3 and right-click on it. From the drop-down menu, we choose the first Paste option. Alternatively, you can use the shortcut Ctrl and V to paste the data. So far, not much of a difference, but we're only just beginning. Let's remove the grid lines on this sheet by selecting View from the top ribbon in Excel and deselect Grid Lines from the Show panel. Excellent. Let's also change the font and font size of our sheet. We'll click on A1 or any empty cell and then press Ctrl and A. This time, all cells in our sheet have been selected. Now from the Home section, we can change the font to Arial and reduce the font size. Okay. The next step is to make the column names more prominent compared to the rest of the table. Let's select cells B3 and C3 and bold them. We'll also click on the grid lines icon and select a thick bottom border. Cool. Let's reduce the width of the A column as we don't require all that empty space. So let's make it around 30 pixels wide. In cell B1, we'll type in a title for our sheet, which will be Used Cars. Since this is a title, it should stand out from the other elements. We can increase its font size to 12 and bold it. Lastly, let's rename the sheet itself to Bar Chart. Great. Now we can confidently begin creating the actual bar chart. Let's select both columns. Then go to the top ribbon in Excel and click on Insert. The Charts panel has a variety of charts we can use to display our data. Not only that, but there is also the Recommended Charts section. Through it, Excel suggests different visualizations we can utilize based on our data. Let's try it out. All right. Perhaps unsurprisingly, the first option we are presented with is a bar chart. In Excel, this type of chart is referred to as a clustered column. The next option is a horizontal bar chart, where the bars are shown horizontally on the y-axis. In Excel, it's clustered bar. Clustered signifies that we can display multiple data series as columns stacked next to one another. Note that with a simplified data set, such as ours, the output of several different types of charts will be identical. Either way, for this lecture, we'll settle on the basic one, clustered column. Then we click OK. And just with a few clicks, we have our chart. It really couldn't be simpler. On the x-axis, we have car brands, and on the y-axis, the number of cars sold. We've got 7 columns in total, representing the number of used cars sold by each one of the 7 car companies. So far, so good. Now, although this chart is displaying the correct information, we can still improve its appearance. Data visualization is not only about creating a chart, but also styling it in a compelling way. Therefore, let's spend some time on that too. With each visualization we create in this course, we'll aim to reach a professional graph with some widely accepted dimensions and colors. First, we'll change the chart size. A chart of this size is optimal for this sheet. The second item on the agenda is to change the font. We'll click on the Home button and choose the Arial font. Let's also reduce the font size to 8. What's next? Now we'd like to remove the fill of the chart and its borderline. Let's left-click on our chart and select Format Chart Area. Be careful not to select an element of the charts, such as the plot area or the axis. Okay, from this newly appeared ribbon, we can control the fill for the background color or the border for the chart's border. For a professional presentation, clean design works best. Therefore, our chart will have no fill and no borderline. All right, we're making great progress. We're now ready to continue with styling specific chart elements. It is only logical we start by focusing on the star of the show, the bars. One idea is to alter their bin size. If we click on one of the bins on our chart, it doesn't matter which one. We see that all are automatically selected. Alternatively, if we wish to select only one of the bins in Excel, we need to double-click on it. Okay, if we right-click on any bin and choose Format Data Series, we'll get a variety of formatting options. Let's reduce the gap between each bar and make it around 95%. Great! What's next? Generally, data visualizations convey insights through shape and color. While the shape is somewhat restricted by the nature of the data, the color is up to us. Choosing a color for our visualizations is of utmost importance and should be thought through carefully. Let's go ahead and pick a nice color for our chart. By selecting the first icon in the menu, displaying a bucket, we can alter the color to a dark blue. It is a very universal color that fits nicely in any presentation. What else? Currently, we can't determine the exact value of each column. To remedy that, we'll insert data labels. We need to right-click on a series element and opt for Add Data Labels. Let's bold them as well. Cool. We now have the exact amount each company has sold. While we're at it, we should address the y-axis and add a label there. To do so, we select Chart Design from the top Excel ribbon. Here, we can select different chart elements. The one we're looking for is a y-axis label, which we add by selecting Axis Title, and then Primary Vertical. Horizontal is for the x-axis. Excellent. Let's name it Number of Listings and bold it. Make sure the color is actual black. One minor change regarding the y-axis. The y-axis ticks are a bit crowded at the moment. Ticks, if you're wondering, refers to the numbers on the axis. To address the issue, let's right-click on the axis and select Format Axis. Here under Units, we can select Major to be 200 instead of 100, thereby halving the number of ticks. All right, it's time to format the graph's title. Let's double-click on the title area and choose a meaningful title for our chart, Cars Listings by Brand. Again, since this is the title, we want it to stand out. On that account, we'll increase the font size to 12 and also have it in bold. For this particular chart, aligning the title on the left-hand side of the visual is a good option. Great. Now our chart is ready. It not only displays the relevant information, but also looks professional. The last remaining step is to save our work. Currently, our workbook is a CSV file, which is intended to contain files of data and not graphics or charts. If we close Excel right now and reopen it, our chart will disappear and will not be saved. This is extremely important, so I'll repeat that. If we close Excel right now and reopen it, our chart will disappear and will not be saved. Therefore, it is crucial to save our file under a different extension. Let's go to File and Save As. In the first box, we'll type in the name of the file. In our case, it will be Used Cars Bar Chart. When we select the second box, a drop-down menu appears, showing us the different extension files which Excel supports. We'll opt for an Excel workbook under the extension XLSX and hit the Save button. Good job, everyone! We've successfully created our first bar chart in Excel. Here, we'll get familiar with the Tableau interface and use its capabilities to make and style our very own bar chart. Let's get started. The first thing we'll need to do is connect to our data source. In our case, we have our car data in a text file with the extension CSV. All right, let's select the Connect to a Text File option and choose the file barchart data CSV. Okay. In this area of Tableau, we can explore the dataset. We can join columns together or filter the data, but this dataset is really small, so we won't spend a lot of time here yet. Tableau is quite intuitive and beginner-friendly. Therefore, we might as well follow its instructions in this pop-up suggesting we go to a worksheet. Let's click on Sheet 1. All right. We blindly followed Tableau's lead and ended up in Sheet 1. Now, before we go any further, let's spend a second to discuss how Tableau is organized and why it makes sense to be here. Tableau uses a structure with workbooks and sheets. This whole area is known as a workbook. A workbook can contain 3 different types of sheets. The first type of sheet is a worksheet, a single view containing shelves, cards, legends, data, and analytics panels. The second type is a dashboard, a collection of views from multiple worksheets. And lastly, a sheet can be a story, which is a sequence of worksheets or dashboards working together to convey information. In Tableau, we have easy access to all 3 through the ribbon at the bottom part of the workbook. For now, we'll be creating with a worksheet. But as we progress through the course, we'll also learn how to create dashboards. Cool. What else? The panel you see here on the left is the Data panel. In Tableau, data is categorized as either a dimension or a measure. So each column in our data will be placed in one of the 2 categories. A dimension contains qualitative information, for instance, names, dates, or geographical data. A measure, on the other hand, represents quantitative numeric information. Tableau automatically sorts the variables into the bins and is usually very good at doing so. If we double-click on car listings and then on brand, we see that we get a bar chart straight away. Obviously, Tableau has figured out a way to visually represent our data. And this is what is so great about Tableau. It is extremely good at guessing our visualization intentions. That could be the end of the lecture, but things are not always that perfect. That's why Tableau also allows us to manually select chart types. There are two ways to do this. The first one is to choose an option from the Marks panel. If we click on Automatic, a drop-down menu with options appears. Let's select Bar. Alternatively, on the right-hand side of the worksheet, we have a Show Me field with different visualization options. For example, we can select a pie chart or a tree map. Some of the options are unavailable at the moment because of the nature of our data. Not all data could be represented with all charts. For instance, if we hover over the map, we see that we need a geographical dimension, which we do not have. Or if we go to histogram, Tableau prompts that a histogram requires precisely one measure. Okay, let's stick to a bar chart for now and try out some of Tableau's styling capabilities to improve its appearance. The first thing we'll do is to enlarge the plot to make all the labels on the x-axis visible. We'll just extend it to the right until we can read the Mercedes-Benz label. What's next? Generally, data visualizations convey insights through shape and color. While the shape is somewhat restricted by the nature of the data, the color is up to us. Nonetheless, choosing a color for our visualizations is of utmost importance and should be thought through carefully. In Tableau, color can be altered through the color mark. We click on it and a panel appears, allowing us to choose a color for our bars and modify the opacity level. In case you are wondering, opacity controls the transparency of the color elements. Through the More Colors option, we can select a custom color for our chart. So far, so good. The color element is a component of the Marks panel, which in turn is an integral part of creating and styling charts. Marks allow us to change and add details to our charts, but there is another neat application of marks. Let's check it out. From the Data pane, we'll select Brand and drag it into the color square. See? Tableau colors our plot by the individual brand straight away. Great! Now, when we left-click on Color and then on Edit Colors, instead of individual colors, we are given the option of different color palettes. Selecting Automatic, we observe 20 or so options. Let's check out Hue Circle, for instance. Once we've landed on a palette, we click on Assign Palette and then on Apply. This sets it as the new color palette for the graph. Feel free to explore the other options on your own after the lecture. Great! There are tons of styling options available with the Marks panel. We'll be exploring those throughout the course. For our graph, though, let's revert to a single color with Ctrl-Z. To make sure our graph is professional, we can choose a dark blue color. It is a very universal color and would fit nicely in any presentation. Brilliant! We're well on our way to making an awesome chart. Now let's direct our attention to the bars and their height. Although we have a scale on the x-axis, it isn't very precise. That makes gauging the accurate value for each bar difficult. If we were comparing the ads between Audi and Renault, for instance, we have to squint to find out that Renault is ahead. Therefore, to display the number of car listings of each brand, we'll add labels. Yet another instance where we'll make use of the Marks panel. We'll drag the Cars measure into the Labels field, and voila! Labels for each bar have appeared. Superb! Next, we'll focus on the text in our graph. We'll start by changing the font. Tableau allows for font formatting on different levels. We can format a particular axis or individual label, or, generally, format the appearance of the entire workbook. In a professional presentation, we want our fonts to be uniform across the whole worksheet. Therefore, we'll opt for the last option. From the top menu page, we'll select Format and then Workbook. Let's go for a pretty standard font like Arial. Once we change it here, we'll effectively change the font for the entire workbook. Excellent. What else? The majority of the work is done, so just a few minor details left. First, we don't require a brand label. To make the visualizations less crowded, we can right-click on it and select Hide Field Labels for Columns. Looks much better. Okay, let's also rename the chart. Then double-click on the field, increase the font size to 16, and bold it for better readability. It's time to type in our new title, which will be Cars Listings by Brand. Remember, having an informative title is an integral part of creating any chart. We'll click Apply, and we have a new title. Excellent! Now this looks like a presentation-worthy chart. All that's left is to save our work. I'm using Tableau Public, which only allows me to save my work on their server. If you already have an account, you can just enter your name and password and save your file on the Tableau server. Alternatively, you will have to complete their registration process. Finally, depending on the size of the file you're uploading, saving it might take a little while. Alright, good job everyone! We've successfully created and saved our first bar chart in Tableau. Creating a bar chart with Python. Let's get right to it. The first order of business is to import the libraries we'll need to create our bar chart. The two essential packages for us are Pandas and Matplotlib. Let's import Pandas as PD. Pandas is a widely used library for data analysis and is what we'll rely on for handling our data. Then, we will also import matplotlib.pyplot as PLT. Matplotlib is the library we'll be using for visualization. Okay, now that we're all set, we can proceed with loading our data set. We'll name our first variable df used cars and use the pandas read CSV method to load our CSV file. Our file is called barchartdata.csv. If your dataset isn't in the same directory as your Jupyter notebook, you'll need to specify the exact file location. For instance, if I were to use the exact path, my code would look like this. Here, it is important to indicate the path with forward slashes between the folder names. This is counterintuitive, as the path locations in your Windows or Mac are always specified with backward slashes. However, in Python, a backward slash has a different meaning. It is an escape character and can be used in conjunction with other symbols. Therefore, always remember to use only forward slashes when specifying a path to a file. Good. After we've loaded the CSV file, we can check what the data frame of used cars contains. It looks identical to the dataset we have already examined. Now let's see how we can translate this information in the form of a bar chart. Luckily, the pyplot module from Matplotlib has a readily available bar plot function. We'll need to type plt.bar. Before we go any further, let's hold Shift and press the Tab button. A window appears allowing us to explore the different parameters of the function. Unsurprisingly, the first parameter is the x-axis. The second, called height, is the y-axis, and so on. We can expand the window with the plus sign and scroll through. Alternatively, we can access a detailed description of functions and parameters through Matplotlib's online documentation. For our bar chart, we'd like to plot the number of car listings by brand. Therefore, for the x-axis, we should select the brand column from the cars listing variable. On the y-axis, which is the height, we'll need the number of cars sold. Hence, from our used cars data frame, we'll take the second column, cars listings. Also, as the last line, we ought to include plt.show to ensure we're able to see our plot, no matter which environment we use. All right. Let's run the cell and check the result. Look at that. Only a line or so of code is all that's required to create a bar chart. Good job! Now, although this chart is displaying the correct information, we can still improve its appearance. Data visualization is not only about creating a chart, but also styling it in a compelling way. Therefore, let's spend some time on that too. With each visualization we create in this course, our final goal would be to reach a professional graph with some widely accepted dimensions and colors. So let's get straight to it. First things first, we want to be able to read all the labels on our x-axis, and at the moment they are overlapping. We can resolve the issue by increasing the size of the plot. The default size is 6.4 by 4.8 inches. We could increase it by specifying the size through the fig size parameter. From my experience, a 9 by 6 figure will be appropriate for most visualizations. Excellent! But there is another way as well. We can avoid overlapping labels by rotating them. Let's try it out, shall we? We'll just introduce an additional line of code, plt.xticks, with a rotation angle of 45 degrees. And here's the result. Rotating labels is an easy way to utilize space without changing anything else in the plot. Now that that's out of the way, let's enhance our chart a bit more. So far, we've been working with Matplotlib, which as a visualization library has a default setting for chart formatting, including font, font size, background themes, etc. Sadly, this particular look isn't everyone's cup of tea. Not long ago, a new visualization library called Seaborn has emerged and has become the preferred choice for many programmers, especially in the field of data science. Seaborn is actually built on top of Matplotlib. As such, the two libraries can be seamlessly integrated and work alongside each other, which is great news for us. To be more precise, we can import Seaborn and set its look to overwrite the default one in Matplotlib. Let's scroll back to the top of our code and try it out. First, we'll import Seaborn as SNS, and secondly, we'll overwrite the Matplotlib look with sns.set to take advantage of the Seaborn styling. In essence, this will allow us to code the graphs in Matplotlib, but they will be displayed with what some call the much superior Seaborn look. Alright, it's time to put it to test by rerunning the last cell of code. Tremendous! Moving forward, we'll be sticking with the Seaborn visuals in the majority of cases. What's next on the agenda? Generally, data visualizations convey insights through shape and color. While the shape is somewhat restricted by the nature of the data, the color is up to us. Nonetheless, choosing a color for our visualizations is of utmost importance and should be thought through carefully. In Matplotlib, we can change the colors of our plot by adding a color argument. Furthermore, we can choose a color name from a predefined color list available in the Seaborn library. Seaborn recognizes over 100 color names, starting from the basic ones such as red, green, or blue, which we can refer to by their initials, RGB, respectively. If you're feeling more adventurous, you can also choose colors such as linen, honeydew, or dark orchid. In fact, you can assign an individual color for each of the bars. Let's see how. We have 7 columns, and we'll assign each their own color. We can type in a string with the following 7 letters: R, G, B, W, Y, M, C. Each of these letters is an abbreviation for a frequently used color. Here's what we get. Cool! Each column has been assigned an individual color. We have R for red, G for green, B for blue, W for white, Y for yellow, M for magenta, and lastly, C is for cyan. This shows how versatile plotting in Python is. We can specify a color for as many bars as we have in this manner. Just bear in mind the color abbreviations aren't limitless. Therefore, at some point, you might have repeats. However, in a professional presentation, we want our color to be uniform across the whole worksheet. Therefore, let's choose dark blue or midnight blue as the only color of our bar chart. You can find the full list of colors in this lecture's resources or check the Python documentation online. Okay, what's left? Well, every plot needs a title. To integrate a title, we type plt.title, and in brackets, specify the desired title. Cars listings by brand has a nice ring to it. Note that you need to put that in quotation marks so that Python knows that it is a string. Let's examine the result. While we've successfully placed a title on top, it is a bit small compared to the rest of the graph. But no worries, everything in Python is customizable. We can increase the font size by adding an extra argument and then specify a font size of 16. We could also add a font weight argument and set it to bold. Here, we could also do with a y-axis label. To add one, we just write plt.ylabel, and in the brackets specify the name as a string. I know for a fact the axis label appear a bit smaller, so let's increase their size to a 13 with the font size parameter. In fact, let's also format the other text elements a little bit, so they look more pronounced. Increase the font size to 13 for the x and y-axis labels, and set the yTix font size to be equal to 13 as well. Marvelous! Our bar chart looks presentation ready. A quick side note. Not all people are comfortable with coding in Python. In fact, you may often need to use your plot outside a Jupyter notebook. To achieve that, you can export your plot as an image. This is easily achieved with the savefig method. In the brackets, we need to specify the name and file format. In our case, it will be a PNG, so we'll have usedcarsbar.png. And that's it. Great job, everyone! Creating a bar chart with R. So let's jump straight into RStudio and start writing some quality code. The first thing we need to do is open up a new script. It is a good idea to begin by saving it under an indicative name such as usedcarsbar.rscript. So far, so good. We'll be using ggplot2. It's one of the most popular visualization libraries in R and a favorite among the community. This is the library we'll be using for the majority of our visuals, so it's worthwhile to take a second and see what ggplot is all about. We're ready to start talking about ggplot2. ggplot2 was developed in 2005 by Hadley Wickham. It relies on a concept known as the grammar of graphics, which is a set of rules for dividing each plot into components or layers. It is also the basis of how each ggplot is created, which is why it pays off to explore the grammar of graphics in more detail. Without further ado, introducing the grammar of graphics. You can think of it as a way of dividing each plot into layers, where each layer is responsible for a specific element of the chart. There are 7 layers we can use when creating a ggplot, and as we delve into different visualization topics, we'll get a chance to explore each in detail. For now, let me give you a quick overview of each of these 7 layers, which constitute the grammar of graphics. The first 3 layers are mandatory, while the remaining 4 are optional. Let's start with the first layer, also known as the data layer. Creating a chart naturally means we require some data. Otherwise, our chart would be empty. Therefore, it is only logical that this is the first and most important layer. All right, what else? We must also decide how the data will be visually organized onto different axes. This is where the second layer comes in. It is called the aesthetics layer. Here we specify the mapping to the X and Y axes. Good. The last required layer is the geometry layer. Through geometry, we specify what shape our data will take. In other words, will the points take the form of bars, circles, dots, etc.? These 3 layers alone are all it takes to create a chart in R. The remaining 4 layers are optional. However, since we want to be proficient at visualizing data in R, we'll master them too. An important distinction between the mandatory and optional layers concerns the order in which they appear. For the first 3 layers, we must start with data, continue with aesthetics, and as a third step, determine the geometries. The remaining 4 layers don't need to appear in strict order. In fact, we don't have to include any of them in our plot, hence the optional part. In this lecture, we list the optional layers in a specific order simply for convenience, but it is not necessarily the order in which they should appear in a ggplot. With that in mind, let's continue with the 4th layer, the facets layer. The facets layer enables us to split our visualization into subplots, according to a categorical variable or variables. Subsequently, each subplot corresponds to a subset of categories of the variables. For instance, say we have an engine type variable in our data, containing diesel, petrol, and electric engine cars. Using the facets layer would allow us to divide our data set into 3 plots, each containing one of the 3 categories: diesel, petrol, and electric cars. So far, so good. Moving on to the 5th layer, which is statistics. This layer represents the statistical transformations we might perform on our data. It can be used for various purposes, such as determining the number of bins when plotting a histogram, or smoothing lines when drawing a regression line. Cool. The 6th layer is the coordinates layer. The coordinates layer, as the name suggests, is connected to the coordinates or boundaries of our graphs. This layer can be used to zoom in or out of a plot. Apart from this, it could be used to perform transformations on the coordinate system. For instance, switch to polar coordinates. Finally, we arrive at the 7th layer, themes. The themes layer has a sole purpose: to polish the appearance of our plot. This is the place that controls the overall style of our graph. For instance, we can choose from darker or lighter themes. Not only that, with the aid of the themes layer, we can use predefined templates or recreate the visuals and style of well-known publications such as the BBC or The Economist, among others. All right. Phew. This is what the grammar of graphics in ggplot2 is all about. You can revisit this lecture if you ever need a refresher or check out the course notes. Or you can just learn by doing. Speaking of which, it's time to create our bar chart. The first step towards a successful visualization is obtaining the necessary data. Therefore, let's load our data file in a new variable called usedCars and apply the readCSV function. As an argument, we need to pass the file to be read. Our file is called barchartdata.csv. If your file isn't in the default R files library, you need to specify the path or directories leading to it. This is counterintuitive as the path locations in your Windows or Mac are always specified with backward slashes. However, in R, a backward slash has a different meaning. It is an escape character and can be used in conjunction with other symbols. Therefore, always remember to use only forward slashes when specifying a path to a file. Okay. We specify the header as true, which means that the first row of our data will be used as columns names. Lastly, we'll indicate that the separator is a comma. After running the cell, the new variable appears in the top right of window R Studio. Next to it is a summary indicating used cars contains 2 variables with 7 observations. Not only that, if we click on used cars, we'll be privy to the entire dataset, a great feature of RStudio granting us easy access to each variable we create. And now on to creating our first chart. We'll be relying on the ggplot2 library, which means we ought to include the library in our script. We achieve it by writing library. When in the round brackets, include the name of library, in our case, ggplot2. Great. Now let's create a new variable, which will be a ggplot object. Now, as discussed according to the ggplot philosophy, the first thing we'll need to specify is the data set. We'll be plotting our automobile data, hence the first parameter to include is the used cars data frame. Good. The next step is to specify the aesthetics, the second mandatory layer of each ggplot. Here, we need to specify which columns will map on the X and Y axis. We want to display the number of car advertisements by brand. Therefore, on the X-axis, we'll have brand, and on the Y-axis, we'll select cars listings. The last mandatory step for completing the plot is to specify the geometry. The geometry shows the shape in which we'll be displaying our data. We'll be creating a bar chart, therefore we'll opt for the geom bar. Inside the brackets, we'll need to indicate a Y aesthetic. We'll use stat equals identity, specifying we want the actual Y values plotted. The reason here is that geometry bars are frequently used to display histograms, which map the distribution of a certain variable. That's why we require the extra parameter. Okay, let's run the code and examine the result. There you have it, our first bar plot. On the X-axis, we have the brand, while on the Y-axis, the number of cars sold. And that's all you need to create a bar chart. But don't go packing up just yet. We still have work to do. For the remainder of the lecture, we'll concentrate on formatting our chart and improving its appearance. It will also give us the chance to get better acquainted with some of the remaining ggplot layers. First, we can decide on the size of the bars themselves. The size is specified using width. For the width of each column, it can take values from 0 to 1. If we select 1, there will be no space left between the bars, making it look like a histogram. We're creating a bar chart right now, so let's select 0.8, leaving us with some space between the individual bars without spacing them out too much. Okay, what comes next? Generally, data visualizations convey insights through shape and color. While the shape is somewhat restricted by the nature of the data, the color is up to us. Nonetheless, choosing a color for our visualizations is of utmost importance and should be thought through carefully. So let's go ahead and choose a nice color for our bars. For this chart, we'll settle on a dark blue color. It is a very universal color and would fit nicely in any presentation. We'll include it as a string for both the fill and border of our bars. You can find a list of available options with the resources in this lecture or online. While colors are very important, having a title and easily recognizable labels is arguably even more important. For the title, we'll add another element called GG title. As I start typing it out, RStudio is already suggesting it. What would be a good title? Cars listings by brand has a nice ring to it, doesn't it? Good job. All right, what's next? Well, since we changed the color of our bars, the gray background isn't as fitting any longer. No worries, we can fix this by assigning a different theme. Recall that theme was one of the optional layers in a ggplot. Though optional, we'll be using it often because the appearance and style of our charts matter. So let's add a theme element to our chart and select a classic theme which has a white background. Very nice. The next item on the list is formatting the axis. Currently, the labels on the x-axis are overlapping in parts, which of course isn't ideal. However, we can amend it and increase space by rotating the labels. As with any styling choice, this is part of the theme department. Let's add a theme element where we'll include a text parameter for the x-axis. We'll give it the text labels with element text and in brackets specify a rotation angle of 45. Lastly, we also add a height justification of 1 just so the labels don't shift after the rotation. I'm excited to see the result. Superb. All labels can be clearly distinguished. Lastly, we don't need the label on the x-axis for this graph, as it is evident from our labels that we are displaying car brands. We'll add a labs function, short for labels, and say that x is null, which will remove the label on the x-axis. As for y, let's set the label to number of listing. Okay, amazing. We have successfully made our first bar plot in R. A great feature of RStudio allows you to export the generated image. You just click on Export and select Image or PDF. Or you could directly copy this image to your clipboard and paste it in a different document like a PowerPoint presentation, for instance. All right. This concludes our lecture on bar charts in R. Moving forward, we'll apply a lot of the techniques we saw here in this introductory lecture, but we'll also learn some new tricks for making quality charts. And I, for one, can't wait. We've successfully crafted our first bar chart and are confident it would serve us well during a presentation. After all, we've done all the necessary steps to ensure it is as professional as possible. On top of that, your audience can easily tell the most widespread brand for used cars is Volkswagen. There is a total of 875 units from Volkswagen, followed closely by Mercedes with 820. Mitsubishi was the least popular, with approximately a third of the listings of the frontrunner. Excellent. We've achieved what we set out to do. Tell the story of this dataset with the aid of a bar chart. There isn't much left for us to comment on this visualization. That is one of the greatest strengths of a bar chart. It is extremely intuitive for all users, regardless of their professional background. But not all bar charts are created equal, so it's worth taking a second to explore what can go wrong when making a bar chart. Let's look at the following chart depicting the average house prices in pounds for the years 1998 and 1999. Visually, it appears from the year 1998 to 1999 there has been a threefold increase in house prices. However, there is a critical error in this graph. The y-axis doesn't start from the minimum number for price, or 0. If we show the same information, but this time with a scale from 0, it tells quite a different story. There is an increase in house prices. However, it isn't as drastic as the first chart would have us believe. By altering the scale, we can easily manipulate a graph to misrepresent information. Of course, this can happen by accident. That's why it's always important to make sure our charts aren't misleading. Such misinformation can also be intentional. This is especially common in political races, where candidates aren't shy to mislead the audience. As a side note, we can, of course, present the first chart with an altered axis scale, if we wanted to show the exact increase in dollar price between the 2 years. However, we need to communicate clearly that this was our intention. Be mindful that even then, it's impossible to be sure that our audience interpreted the information as we intended. All right, tremendous job, everyone. We've reached the end of our first chapter on data visualization, and we're already able to create as well as style charts in a professional manner. Well, it seems we're equipped with all the tools required for creating amazing charts and can confidently proceed with other fundamental topics. Stay tuned, and thanks for watching.